I do on 40 is draw a diagram, which is what most of you did. So he's at the top of the oil rig. So here's my oil rig, here's the water, here's him, and here's the golf ball. It says he hits the golf ball with a velocity of 65 meters per second. So here's my velocity. So that's 65 meters per second. The oil rig is 80 meters above the water. And then he's hitting it into a group of protesters which are on a boat. Which evidently the protesters are taller than the sail on their boat. It's not a great design choice. And the boat is 10 meters above the water. So the question I got from most people, and it wants to know how fast is it going then. So the question I got from most people is, what on earth do I do after this point? So this is a good time to figure out what equation are we going to be using. So when I'm looking at my equation, so this is an energy problem. There we go. Here's the energy ones. Okay, so this is an energy problem, and there's a bunch of different equations. So this is the equation for figuring out work done on an object. This is just gravity that we use for sometimes, like if we're lifting against gravity. This is the power equation. That's pretty straightforward. These are kinetic and potential, also straightforward. This is just to remind you that work causes an energy change. When you do work on an object, it causes its energy to change. And then lastly, we got this equation here. So this equation is conservation of energy. And this is the equation that's used if we're talking about how an object changes between A and B. So in the diagram that we drew, you can see that that's what's going on here. We have an object at A. We'll call A up here at the top. And it's going from A to B, which we'll call here at the bottom. So I find it helpful to kind of identify the equation here and say to myself, okay, this is conservation of energy. The W is in parentheses because you only include W if there's work. The problem said nothing about work, so we don't need to worry about it. So the equation we're going with here is the kinetic at A plus the potential at A equals the kinetic at B plus the potential at B. Now, there's one part of the diagram that some of you did and some of you didn't. And the last thing you need to do on the diagram is you need to label where 0 is. So you need to decide what your height of 0 is. Now, if you don't know, then you should just make the ground 0. In this case, the water. So I'm just going to go ahead and write h equals 0 here for the water. Now, you don't have to make the ground 0. I saw some people choose to make the boat 0, which is what I would have done. Okay? If you do that, make sure to change your height of the oil rig, because the height of the oil rig now isn't 80 above the water. It's now 70 above the boat. So keep that in mind. So now we can start doing our knowns and unknowns. So for example, the mass is 0.1. Then we have the height at A. So the height at A is 80 meters. Again, I'm doing the water is 0. And my velocity at A is 65. Okay, then at B, my velocity and my height. So my height at B, it's 10 meters above the water. And my velocity at B is what I'm solving for, because that's what I'm trying to figure it out. So now I need to find these values here. And I do that by using kinetic and potential energy. The kinetic energy equation is 1/2 mv squared. That's here. You don't have to memorize it. And the potential energy equation is mgh. That's here. Again, you don't have to memorize it. Little g is 9.8. Don't make it negative 9.8. Just make it 9.8. All right. So here's where I want you guys to go from here on 40 now. Find kinetic and potential at A and at B using these numbers. Then plug them into the equation and then see if you can solve what you're looking for. All right, I'll come around again. See what questions you have. So once we get to this point, we need to find the kinetic at A and the potential at A. So the kinetic at A is 1/2 times the mass times the velocity squared. I saw several people forget to square the velocity, so just be careful with that. And again, like I say, I'll say be careful a bunch because you need to be careful a bunch. So that number, kinetic energy, is 211.25. Okay, then I need the potential at A. That's mgh, so the mass is 0.1, g is 9.8. And the height, again, I'm doing it the height above the water, so it's 80 meters above the water, so that's 80. So 0.1 times 9.8 times 80, 78.4. All right, then I need to find all those values for B. So the kinetic energy at B, so that's 1/2 mv squared, so 1/2 times 0.1 times the velocity squared, but I don't know what the velocity at B is. So I'm just going to say question mark here, or X, or whatever you want to do. Okay, and then the potential at B, mgh, so 0.1 times 9.8 times the height, which height above the water for the boat is 10. And that's going to be 9.8. Okay, so once we've got all that stuff set up, knowns and unknowns, drew the diagram, set up my kinetics, now I'm ready to do something with it. Now I'm ready to plug in and set up my equation. So the equation is kinetic at A plus potential at A equals kinetic at B plus potential at B. So the kinetic at A, 211.25. Kinetic at B, or sorry, the potential at A, 78.4. Equals the kinetic at B, which I don't know, so I'm just going to write KEB. Plus the potential at B, which is 9.8. So to get kinetic at B by itself, we're going to subtract the 9.8 over and add those numbers up. So 78.4 plus 211.25. Nope. 211.25. Okay, minus 9.8 gives me 279.85. Now, that's not the final answer yet. Okay? That's not the final answer because that's the kinetic, and I asked for what's the velocity. So, now I need to plug this kinetic number back here where I had it. So, KEB is 279.85. Equals 1/2 times the mass times velocity at B squared. So divide the 1/2 over, divide the 0.1 over. That'll give you VB squared, so 5,597 equals VB squared. I don't want VB squared, so I got to square root both sides. 74.8 meters per second. So a couple other minor things you could do. If you wanted to call the boat 0, then this height would be 70 instead of 80, and this whole value for PEB would be 0. Okay, that means that your equation would be some number plus 0, or some number plus some other number equals KEB plus 0. So that would make solving it a little easier just from an algebra standpoint. But it won't change your answer. You'll get the same answer. Okay? All right, any other questions on 40?